The Aldis podcast is brought to you by Aldis International, supplying your expert AI and digital transformation staffing needs across the US and Europe. Today, you are listening to our AI in Action series, where leading minds in AI from across the world share their story, success, and advice. AI in Action cuts through the hype and explores the true impact of artificial intelligence in our world today.
You're listening to AI in Action. I'm your host, JP Valentine. Our guest today is Paul Powers. Paul is the founder and CEO at Physna. Paul, welcome to the show.
Thank you for having me.
So Paul, let's start with yourself, please. Could you give us a bit of an overview of your journey in technology from where you got started, some of the roles you've held along the way, and take us up to today as the founder and CEO at Physna?
Absolutely. I grew up homeschooled in the Midwest, and as a result of being homeschooled, the peers, people I compared myself to, tended to be more people I would read about. And so from a very early age, my life mission has been to have the biggest, most positive impact that I can in my lifetime. And at first, I wanted to do that through science and technology directly as either a scientist or a technologist as an individual contributor. So I actually started studying astrophysics at Harvard. I got to go there younger because I was homeschooled. So I went there at 16. But while I was studying, I very quickly realized that nowadays the best way to have the kind of impact that I was looking for was to actually start a company. And I had started a company to afford to go to college in the first place, and I sort of got the bug. I fell in love with being an entrepreneur. So it was clear to me that was the path that I wanted to take with my life. I still wanted to get a degree, and because I grew up homeschooled, I wanted to see more of the world. So I actually went overseas. I learned German and ended up studying German law at the University of Heidelberg. And that was hard, but I wanted to do it because I thought it wanted to be fun to prove something to myself. But that'd be neat to prove to myself that I could do that. And in the process of roughly 10 years of learning German, then going through all the way through law school, I started and ran a few companies to pay the bills while I was over there. And ironically, the idea for Physna came from a simple issue that I ran into in that process of getting the law degree. And that was in patent law. We just couldn't find 3D models. And I tried to solve that using different products that were on the market, different things that sounded like they did shape search, geometric search, what have you, but they didn't work. They were really bad at it. And the more I dug into the issue, the more I realized that there was this fundamental piece missing in technology. There wasn't a good way to understand how 3D models are related to each other. There wasn't a way to codify them, so to speak. And so that wasn't a problem that was limited to that one narrow use case of patent search. That was a universal problem. And I knew there had to be a better way to approach it. And that if you use the right mathematics, you use the right types of deep learning, there probably is a way to solve that effectively. And so with that in mind, I started Physna. And years later, after I moved back to the US in 2015, started Physna, started working on Physna around then, officially made it a company in 2016. It took a long time and a lot of work to actually make it work. But now today it's extremely powerful. Physna essentially is to things what binary code is to images, sounds, text, what you on a flat screen, if you will. So Physna is short for physical DNA, and it really does codify what's physical or three-dimensional. And essentially, if you're a coder or a user, it lets you do anything with real objects or with 3D models of real objects that you could do with code, text, etc.
Thank you for the background, and you've already answered what is usually my follow-up question about where did you get the idea for Physna. Tell us about your mission and what you're doing. That it's a really clear mission and born out of a gap in the market, like many tech companies. So I want to learn about the journey over the past few years from when you officially launched the company to where you are now. What were some of the milestones? What were some of the major challenges you faced, whether it's you getting access to data sets or just applying the machine learning and algorithmic models to help you solve this problem? Take us up to it in its current format, just how successful it's been.
Absolutely, happy to. So the hardest thing by far was getting the code to work. It was like inventing the light bulb. We discovered thousands of ways to not make it work, and one day it actually did. So it was really tough. I can't tell you how many hundreds or thousands of man hours were put into trying to get something to just work at all in a consistent way. Keep in mind, like the benchmark that we set for ourselves was really high. Things that were called like geometric search or shape search or whatever, they really were essentially doing something similar to image compare. And there are so many ways to break it. Those tools didn't work. And so we didn't want to hit that bar. We wanted to think of it like we have to be able to match the objects and their attributes and their geometry the same way that you would be able to match like code or text. So everything down to any overlapping shape or component, or if I were to throw a vase against a wall and somebody had all the shards, we could tell you not only that the shards belong to the vase, but actually how to reassemble them and put a vase together. That was the requirement without any cheating. So no metadata, no bill of material or anything. It had to be purely mathematic. And that was insanely hard, but we finally got that to work. And after we did, that's when I started to feel comfortable enough to start looking for real investment. So before then, it was I did everything I could to pay out of pocket until I knew there was something there. And then as I felt a little more comfortable that we were headed in a direction that was going to result in something, raise some money from friends, family, some small or individual investors. And then when it started to actually turn into a real product, 2019 or so, we actually raised our first institutional round. So we called like our Series A. And then with that, not long after, actually, my co-founder passed away. He was a CTO. And that was hard in the company because, I've got a strong math background and I can understand code to some extent, but I definitely am not as qualified as he was as a CTO. And so we spent a long time trying to find someone. We ended up hiring Dennis DeMeyer, who in early 2020, and he's fantastic. He was in the office of CTO over at Google and spent 6 hours with him in Mountain View explaining why he should leave Google, take a huge pay cut, and come out here and join this company. And luckily for us, it worked. And he did. And he's been hugely helpful and influential here at the company. And that was around that time we were starting to launch Thangs. And so he came in and was able to bring that to the next level. So with Physna, it's both the name of the company and also the product. So the product is a series of APIs. We did build a SaaS interface. So there's like an actual enterprise SaaS product that we built. What we found out though is that the number of, even though we knew this was a universal problem, the number of use cases was overwhelming. And so there were, to put in perspective, in the first couple of years, when we just barely started talking about this product, we didn't really even market it. We had over 300 use cases from a couple hundred, or from over 100 companies. And they were all, 300 unique use cases that we had validated and said, yes, the technology can do that. But we don't have the user interface for every single one of those use cases. So you can create something that kind of works for everybody, but isn't great for anyone. Or you can you can create APIs that allows people to do whatever they want, however they want. And then we ended up, after we had some success with sales, we have great customers, not both in the Department of Defense and the Fortune 500, and also smaller customers, and increasingly there are technology companies that are using these APIs. We realized that having a SaaS platform wasn't going to be as impactful as having APIs. So these APIs now are the backbone of the company, and they're used again for things like, there's so very many use cases for it, but a good example is so some of the larger manufacturers use it for things like speeding up engineering. So think of like autofill. You start to design something. If we've seen what you've started to design already before, we can recommend other models for you. If you have duplicates in your database, we identify that because we know how all models are related. So we can say, hey, procurement, you're ordering the same thing from 100 different vendors. Stop doing that, please. You can standardize and order all of those from one company, and you'll save a lot of money. In fact, huge amounts of money. It's actually shocking how many duplicates every company we've ever worked with has had. It's also useful for people out in the field. One thing we've learned is that our understanding of geometry gives us a much better understanding of things like imagery. And so we have one API that is a 2D to 3D search. And so you take a picture of something, and that could be a drawing, that could be something in real life, or it could be even a blueprint. And we can match that to a 3D model infinitely more accurately than you could ever search for something with 2D to 2D. And so the 3D data that we have lets us learn about how to search much more accurately, both not only from 3D, but also from 2D as well, and from text, because whenever we have information about these models, we can see how the text associated with those models relates to the geometric relationships, if that makes sense. So we can quickly figure out, oh, this part didn't perform well, that means this other part probably won't, because by looking at these models and seeing how they're labeled, we know that there's this one component they have in common that causes an issue or that is called whatever. And the machine learning opportunity is actually tremendous. Whenever we get a new model or new data in Physna, we're able to do just tremendous amounts of things with that, much more than you could do with any traditional neural network alone. And anyways, that's Physna. What we realized though is that there's a bigger trend here, right? The reason that 3D matters so much is that there are a few things in technology that I think you can never say are inevitable. I think the internet was one, because having the internet and that connectivity would give anybody using it an unassailable advantage to anyone who didn't have it. The next era of technology as a whole, I think, is inevitable as well. And that's that technology will be closer to omnipresent and much more immersive, smarter and more tailored to you, and not relying on input on a flat screen so much. So in other words, more part of reality. And the problem is that if you want technology to be part of reality, it has to actually understand reality. So you need the ability that software has to have spatial reasoning. It has to understand the physical environment, the three-dimensional environment around you, and that didn't exist. And so even today, less than 1% of all software can support 3D content at all. And so what our APIs do, not just for those end customers that I mentioned, but also now increasingly for software companies, for startups, for coders, is we don't pretend like we have the final solution for everybody as an end product, but we do have these APIs that power them. And so these APIs make it possible for anybody to build whatever they want now, because they can code a software program to do the same thing they were doing with code or text or images or sound. They can now do that with physical things and models, however they would like. So anyway, that's the Physna side. The reason that transitions into the Thangs. The other thing that you need, though, in this new era of technology, isn't just the ability to work with this data. You actually need the data itself. So how do you go about getting enough content? The content's out there, but it's a nightmare to find it. And it's also really hard to find 3D content, right? So, not just find it, but to create it as well. So we launched Thangs.com, and it is exploded overnight. It's a much newer product than the APIs are. And it's already now by far the world's largest 3D search engine. It uses the core technology that we have here to find models and then relate them, not just from models that are uploaded by users, but also models that were crawled around the web. So it really is like a Google for 3D. And beyond having that search capability, again, not just with text, but also with the geometry itself, the core technology that we have, we've added tools to Thangs that have made the creation, especially the collaborative creation around 3D content, much easier. Creating 3D models is actually pretty difficult. And that's a shame, because demand is about to explode with Apple Glass, the new so mixed reality headset that's coming out from Meta, to the next generation of Oculus, so to speak. And there's this huge demand that we're going to have for 3D content, but it's really hard to, one, get that content, to create new content. And again, there are a few apps that can support it. What we did with Thangs is we created this collaborative technology that's really like the GitHub for 3D. And we didn't do this blindly. We worked with, so at the time he was CTO at GitHub, Jason Warner. He joined our board back in 2020 as well. He now has since left GitHub, but he was CTO over there at the time. We also worked with Jeff Weiner, who is the CEO over at LinkedIn, because there's a social network aspect to this, as well as Dylan Field of Figma, because obviously that's the collaborative platform in a more two-dimensional sense. And so with their input and input from users, we've put together capabilities and things now that make 3D creation and collaboration much more like collaborating together on a Word doc or in a GitHub type of environment if you're in software. And the vision is that soon, in the not too distant future here, creating 3D content will be literally as simple as type.
You are listening to the Aldis Podcast. When you're looking to scale your team, or if you are interested in showcasing your company in a future episode, reach out today. Or if you're in the market for a new role, visit our website to view open positions, www.aldis.com.
I want to spend some time now talking about the team that has built this. Can you describe the current AI data team at Physna? How many people, what types of positions, and what sort of backgrounds they've come from, and how you've gone about building the team?
That's a great question. We have a very diverse team here at Physna, and we think it's really important that we bring in people from not only different walks of life, but different companies. And so we have former Googlers, we have former employees of Microsoft, of Amazon, of Meta, basically all the FANG companies. But then we also have people who played, pivotal roles in various startups that are either related to 3D, or at least their role was very related to 3D. And that's obviously full stack. So we have people who focus on AI, machine learning, deep learning, neural networks, et cetera. We have people who focus on more algorithmic parts of R&D. We have people who focus on the back-end architecture to make everything scalable. And of course, we have front-end developers as well. So the company is almost overwhelmingly engineers. It's about 80 to 85% of the company right now, if not more than that, is engineering versus anything else. And so our headquarters is in Columbus, Ohio. But I would say about half of the company is spread out throughout the United States. So half of them are local and go into the office and as they choose to. Obviously, in the era of COVID, we don't mandate that people are in the office literally every single day, but we have it here. It's a great way to socialize and collaborate when needed. About half of the team is external.
I want to stay on the topic of team because it leads nicely into what's next for Physna and Thangs. Obviously, proof of concept is there, and we're now moving into growth and scaling phase. So, looking at the roadmap ahead, particularly the next year to 2 years, what are some of the major things you're working towards in terms of market growth, whether it be servicing different industries, adding to the data sets? With that growth, talking about the team, where is the team going to be 2 years from now? What sort of hiring are you going to need to make?
There'll be a lot of hiring that we'll need here in the future. Right now, obviously, the overall economy is in a tough spot. If that weren't the case, we would be hiring people a lot faster. But we have to be, of course, a little careful in the current economic environment. You don't want to burn through cash faster than you have to. But as soon as either that goes away or more likely our growth accelerates even more and we actually need more people, then we'll be hiring engineers, especially in, this is a very generic, wide area, a lot of people in deep learning. We'll be hiring additional people in app development and really just expanding on. I think we have actually a pretty good mixture of people and types of areas, but we would need to expand upon the number of people on the team and probably maybe double that in the next year or two as far as the team is concerned. Things that we'll be working on, though, to answer that question, this will explain it better probably. So one of them is, again, taking that concept of Google plus GitHub for 3D to a whole new level where it becomes even more automated, the collaboration process or the design process, having more plugins to more platforms, making it so that the moment you start to design something, we're able to help you finish it and say, hey, maybe this is the next step. Maybe this is what you're trying to design. We're also looking into things in the AI or generative design space as well, something that we're also looking into. And we have, I think it'd be fascinating. It's just, I think, so let's put it this way. In the past, when we had the last major technological revolution with the internet, I remember when my family bought a computer for the first time and seeing the internet back in the dial-up days when you would fight with your family about, can I make phone calls or be online? And I remember how quickly that changed our lives, and that change only accelerated. But we're now entering a time just like that with the metaverse. And with Thangs, you'll be able to find any content you want, create content easily. And again, these APIs open up the world of AR, VR, MR, metaverse, other 3D applications to all software developers, all startups. And that's not hypothetical, we're already seeing it. And so where we're going is that you'll not only have experiences through these new applications that are coming out and through our own that are more immersive and that are more tailored to you, but you'll also ideally have more control, more creative power than you did in the past. Today, you rely on designers to choose what figures look like in games and what kind of experience are you going to have in software. And I think that's going to be different in the future. It'll be more dynamic and easier to modify or create things with zero training. And to me, that's the ultimate empowerment of human beings, is to tell them, hey, you have control both for yourself and creatively, maybe for others, to unleash your full creative potential, even if you don't have formal training in how to design something in 3D or whatnot. And that's, I think, what we're headed towards, is trying to democratize that creative process for everybody. And the great thing about 3D is that it'll be not only for the future software world, so the future of the internet, of this immersive mixed reality type environment we're moving towards, But you'll also be able to, if you wanted to single it out, you reuse those things that you've designed or worked on either in a gaming environment or in real life and have that manufactured or built for yourself. So you can really shape the world around you, both figuratively and literally.
Paul, thank you so much for coming on today and talking to us. Great to learn about your own background and the origin story behind Physna, which is also now Thangs. It's incredible the marketplace that you're creating, certainly an early adopter in a space that is only going to grow over the next few years. And given what you've told us here today, I'm super excited to see what you guys can accomplish and in this space as a whole. So we wish you all the best. We look forward to having you back on the podcast in a year or two from now to hear about what's happened since then. So good luck to you and the team. And yeah, we'll talk to you soon.
Thank you. I appreciate it.
Thanks for listening to this episode of the Aldous Podcast. If you enjoyed today's episode, don't forget to subscribe, rate, and review. We are available on Apple Podcasts, Spotify, and any Android podcast of choice. You can also head over to our website, www.aldous.com, to listen to more podcasts, view our open roles, and stay up to date with industry news. Thanks for listening, and stay tuned for more great episodes coming very soon.